Hello, today I will be teaching about binomial distribution. What is binomial distribution? In binomial distribution, there are only two possible results which can be labeled as success or failure with probability of success P being the same for each trial. Also, trial is independent from each other, as in knowing one trial doesn't influence the next trial. Still confused? To understand it better, let's look at its formula. So this is the formula. In some books or other universities, maybe the pi is a p instead. Regardless, it means the same as it's meant to represent the probability of success or failure. The x here is a random variable, or what is the thing that we want to observe, like for example, a number of students who pass the exam. I forgot to mention that binomial is a discrete. Since it is a discrete, that means n is a whole number. So there will be no such question as let's say 2.1. Like at that point, it will be a different distribution that you will have to use. Moving on, I have already mentioned the pi or p means the probability of success or failure. N means the number of trials. In case of trying to find the exact success or failure, this is the formula. This one here, the NCX, I would personally prefer using this one instead just because it's pleasing in the eyes. At least, it makes it easier to differentiate the N and X. But the one above is something that you won't exactly type on your calculator, the NCX. Again, it depends on your preference. And binomial also has its own mean and variance formula to use. And it also has the statistical table for binomial, something that you need to use if you're taking statistics. This is something that you should already prepare. Regardless, this is one of the example on its table. The purpose we need it is to save time and reduce error instead of using the equation. Of course, in some cases, there will be no option, like they want a specific number of pi, like 0.656. Now, that's where we have to apply the formula equation. So, to understand what I mean, let's look at the example question. So, let's apply what we learned. For example 1, we do a very straightforward question here. So, find Ex less than or equal to 1. We extract the information first to make it easier to understand. N is 3, pi is 0.1. While we're at it, I show you how to read the stat table with the information provided. So, over here, since this is a cumulative binomial table, that means that X less than equal to X. So, since the question asks for X less than or equal to 1, with N is 3, and the pi is given is 0.1. So 3, 0.1, and it says is less or equal to 1, which here, so this will be our answers, 0.9720. The answer will be 0.970. So next is Ex equals to 3. The equation want the exact 3, so there are two ways to solve this. One is to use the equation, or we can use this stat table, and the way of this method is to use some imagination. So let's draw something like this first. So we want exactly 3 from this drawing or graph. Cross this, which can be translated to x less than or equal to 3, which is the whole thing including the 210, but we're still not done yet as it's not exactly equal to 3. So next, we'll cross this just until 2. So this will be translated to p x less than or equal to 2. So we see here, this is our answers located. Since this is a discrete, there is no in between the 2 and 3. So we can imagine that this is already just a 3. So x equals to 3 here. So to get our answers, we minus both of these. So it will be x equals to 3 equals to x less than or equal to 3 minus x less than or equal to 2. So this is our answers. So according to the stat table, it will be 1 minus 0.9990. The final answers will be 0.0010. So if you're still struggling to understand the graph, I can do it one by one. So yes. So we draw the graph back 1, 0, 1, 3. So since the answer that we want is to get the exactly 3, try to cross all of this first. So again, like I said, it's p x less than or equal to 3. And then we want to like remove the whole thing to get only this part of the graph. So we minus width and to remove this, so they will be x less than or equal to 2. So can you imagine, like if this both the 3 minus the 2, so then it will result in only having this part between the 2 and 3, and this is the x equals to 3. I know it can get confusing sometimes, but I still recommend using this method as some question can take too much time if it asks you to get something like between 10 and 20. And you kinda don't want to calculate it one by one with 10 long equations, as you can imagine. So we try to stick with this method as long as there's information in the stat table. So next is x less than 3. So you see here it is less than 3, meaning that not including 3. So it will be just 0, 1, 2. So the answer will be x less than or equals to 2. So according to the stat table, the final answer will be 0.9990. So next is px more than 1. Now more than 1 here can also means there's no ending to it until infinity. So to solve it, we use 1 here, meaning 100% of probability. So if we were to draw it, it will look like this. So 1 till infinity. So this represent 1. And also I will draw the write the in between, and this means 2 infinity. Then we want to get rid some of it to just get the final answer to be more than 1. So get rid of the 1 here. So the final answer will look like this. 1. Then we will get the more than 1 here. 1 translate to p x less than or equal to 1. So the final answers will be 1 minus 0.9720. So this will be our answers. Lastly is px more or equal than 2. The same as before, as long as you can imagine and make sense of it using the drawing or graph, you won't get it wrong. But still, since this is a practice, I will show it again. So the whole thing is 1. So if we were to draw again, 1, 0, 1, e, the in between 1, okay. So this represent 1 minus so since we want the end results more or equal to, we cannot do this, since this will mean p x less than 2, because this will like get rid of the 2 as well, and our final answers will be p x more than 2, which is false because we want this. So instead we will get rid of 1. So this means that it is a p x less than or equals to 1. So after this, the final graph will be look like this: 0, 1, 2. Now this one will be p x more than or equals to 2. Again, we want to include the 2 as well. So we always get this wrong because this is actually equals to 2. So 1 minus p x less than or equals to 1. And then the final answers after using from the statistical table. So the final answers will be 0.08. This will be our answers. Now we can try a real exercise example. So in example 2, the question is, while investigating a product safety case in Statistic, you discover a company sells luxury bathroom tiles in box of 20 tiles each. According to the investigation report, the probability that a tile is defective is 0.1. Tuna selects one box as random from the warehouse for evidence analysis. So question 1, it asks, what is the probability that exactly 3 tiles in the box are defective? So firstly, let's extract the information we have. We have n equals to 20 and pi equals to 0.1. 20 and 0.1 which is the defective. So put in the binomial formula, which is here. This represent the defective tiles. So we want to find P x equals to 3. So like we have in example 1, so will be P x less than or equal to 3 minus P x less than or equals to 2. This will be equals to 3. So 0.6670 minus 0.6769. The final answers will be 0.1901. So for question 2, what is the probability that the box contains no defective tiles? So no defective tiles means that Px equals to 0 because no defective tiles. And our binomial probability is for the defective. So it makes sense for the Px equals to 0. Since it is equals to 0, we can either use this, the equation, I already inserted the numbers, or we can just use the stat table because it's just quite literally a 0, so the final answers will be 0.116. Question 3. What is the probability that more than 5 tiles in a box are defective? So more than 5 means that Px more than 5. So if you already master the graph method, then you can just do the final result. What have you imagined? So for x more than 5, that means that we want the end result will be look like this for our graph. So if something is more than something number, so automatically assume the 1 means the 100% probability. 1 minus, can get rid of this 1. The in between here is so meaning that Px less than 5. So 1 minus 0.9887. The final answers is 0.0113. Question 4. What is the probability that at least 4 tiles are defective? So at least here means that p x or equals to 4. So since it is more or equals to 4 means that it has to include the 4 as well. So our final graph should look like this. Should look like this since including 4. So 1 minus, get rid of the 3 and below. So means that p x less than or equals to 3. So 1 minus 0.8670. The final answers 0.133. Question 5. What is the probability that from 2 to 4 marks are defective? So from 2 to 4 means that P 2 x 4 means that including the 2 and 4 as well. So if we were to draw 2, 3, 4, so solve this, we will look at the highest number first. So we will cross all of this. So that means that this is p x less than or equals to 4. And then since we want our final answers to be in here, which is plus to 4, then to get rid of this means that we minus, means that this is p x less than 1. So according to the stat table, it will be 0.9568 minus 0.3917. The final answers 0.5651. So finally, this can get a bit tricky. So the question asks, as part of a corporate fraud investigation in Statistic, the legal team reviews a contract showing that an interior decorating firm purchased 10 sealed boxes of tiles from the manufacturer as evidence. A box is clarified as perfect if every tile inside passes inspection with no defects. What is the probability that at least 2 of the 10 boxes submit as evidence are perfect? Since this is still part of the original question, so the x is 0.1, which means the defective, in case of the defective tiles, this one still exists. But this time, we will also make a new binomial distribution for the perfect condition of tiles. I put in y, do not confuse with the x, so yb, and for n of the for n, we look back at the question. If it asks for what is the probability that at least 2 of the 10 boxes submit as evidence are perfect. So 10 here means n, so 10 here, and then perfect is the pi. So the pi, since if we look at the defective tiles version, so if it is perfect, that means that it will be px equals to 0, meaning no defective at all. And we have already solved this from the previous question, which is this one. So this will be our new pi. So our new pi is 0.1216. This is in the perfect condition. So now we can solve the question. So it says at least 2. So P pi more than or equals to 2. So means that immediately we will think 1 minus. So now we try to do the graph method. So more or equals to 2 means including 2. So our final graph will look like this. 1 minus, get rid of this. So means that P x less than or equals to 1. So the thing about this is we cannot really solve this using the stat table because our pi here is 0.1216 and it does not really, this number does not really provided in the stat table. So what we do is that we will have to do it manually using the equation. So 1 minus, so here is, since this is less than 1, so means that 0, 1, including the 1. So, y. So Py equals to 0 plus Py equals to 1. With this, we try in the calculation. So this 10 is 0. And if you're using the calculator, be careful because sometimes in my calculator, I have to exactly input the multiply to actually for it to calculate my calculation. Since I'm using the older model 570ES. So here 0.1216 0.8784 10 plus 10 1 right, multiply, just insert the number. So the final answers will be will be 0.3479. This is our answers. So that's all for binomial distribution. In the next videos, we will try to answer more questions on binomial distributions. So I hope to see you next time.